the third edition of Epsilon. Myself, Aditi Kurhekar, the Joint Secretary at IEEE SIS GST.
I am Xenia from Creative Head IEEE SIS GST. Um,
We are honored to be your host for this session. The previous year's symposium, Epsilon 2022, was an effort of IEEE SIS GST that proved to be incredibly instructive and fascinating. Now, we are even more excited to kick off the third edition of Epsilon today. This year, we bring you Epsilon 2023 with the theme The Galaxy of Intelligence. This 3-day symposium is distinguished into 3 tracks: WI, CS, and MTTS, where industry experts from various fields will share their expertise of their respective domains. This symposium's first track is WI with the topic Nero AI, where we'll be discussing the inner workings of AI created personalities and GANs in focus. Today, we have with us Mr. Pranjal Jain.
we anticipate that. Okay. Should I continue? We anticipate that the first session of the day, an introduction to AI, will provide you with a plethora of information and introduce you to many new ideas. And now, for the first talk session of the day, we have under the WI track of event an introductory session named Creating a Virtual Person. Doesn't it sound great?
Absolutely. Just a little background information for the attendees before we start. The tasks and quizzes we've planned for each day of our symposium will test the attendees' familiarity with the subjects covered in each session. The link of the quiz will be sent in the comment box at the end of the session. Kindly do participate. Each participant will receive a certificate. Now, let us begin with our most awaited session by welcoming our first guest speaker for the day.
We have with us Mr. Pranjal Jain, a distinguished alumnus of the IIT Kanpur, and we are honored as a gold medalist for the class of 2022. He has authored an in-depth thesis on the subject of blockchain, and he had made significant contribution to the development of 5G technology. Also, he has demonstrated outstanding accomplishments in the fields of full stack development, artificial intelligence, and blockchain. Throughout his career, he has personally trained over 2,000 students who have gone on to secure position at multinational corporations such as Microsoft, Google, and Amazon.
Welcome, sir. We are very grateful to have you with us today and are looking forward to this really incredible session.
Thank you so much for the introduction, guys. So I'll start with my session. A very good morning to all of you who are attending, and I'll just give you a brief overview of what we are planning to do today. So what I'll do today is I'll give you a brief overview of GANs, what GANs are, what their capability is, etc. GANs are much more mathematical than what we'll discuss today. The maths is very deep and has to be explained in a different manner completely. So we'll be skipping out the maths and we'll only be focusing on the theoretical part for the day. So let's see, if you're interested, you can connect with me and we can deep dive into it together, because this is a topic that interests me a lot as well. So let's get started. So today we'll be understanding generative adversarial networks. So what are GANs? Right. So what exactly are GANs? In simple terms, they are a type of artificial neural network used to generate data that wasn't there before. Imagine being able to create a new piece of artwork or a realistic face or even a video game environment. GANs can make all of that possible. So ChatGPT is one of the major applications of GANs that have gone viral over the past few years or the past few months. So why are GANs so important? They have numerous applications ranging from art, entertainment to solving complex scientific problems. They are a cornerstone in machine learning and artificial intelligence and have the power to transform industries. Today, we'll explore GANs from their basic components to the ethical considerations surrounding their use. Let's have a look at what the agenda is for today. So, first of all, we look at the components of GAN, then how do GANs work, applications of GAN, a few case studies where GANs are working currently and have given excellent results so far, ethical considerations, limitations and challenges. Then we look at a few advanced topics, and finally we'll conclude and open the session for a Q&A session. Okay. So our goal is to provide you with a comprehensive understanding of GANs, how they work, where they can be applied, and the challenges and ethical considerations that come with them. So let's get started. So the first thing that we have to learn about is the generator. So let's start by discussing one of the main components of GAN, the generator. What's its role? Simply put, the generator is the artist of the system. Its primary job is to generate new data. So this is the part that deals with generation of new data. Imagine the generator as a counterfeiter trying to create a fake currency note. It takes in a random number as input and outputs an image that it believes resembles a real currency note. Over time, the generator becomes better at creating realistic images. But how does it improve? So what happens is initially it is not making such good output, but over time, as it keeps training, it keeps on giving better and better results. How does it do that? It learns from its mistakes and adjusts its tactics based on feedback from another component, the discriminator. We'll get into that in just a moment. So the key takeaway from this is the generator aims to produce data so convincing that it becomes indistinguishable from the real data. So that is the main purpose of the generator, to generate images or any kind of data that you want that is completely indistinguishable from the real data. Okay, so you won't know which image is real and which image is fake. So this brings us to the second component, the discriminator. Now let's talk about the other central figure in GAN, the discriminator. If the generator is the artist, think of discriminator as the art critic. Its primary role is to evaluate the data it receives and distinguish between real and fake. If we go back to our counterfeiting example, the discriminator acts like a forensic expert, examining the currency note to determine if it's genuine or counterfeit. In summary, the discriminator's purpose is to get better at distinguishing real data from the fake data, providing feedback to the generator in the process. So we'll just see what kind of a game these two components are playing with each other, but just know that they work together so that the output is as realistic as possible. We'll just see how they work together in synchronous. So this brings us to the next topic, the game. What is the game that these two components are playing? So how do the generator and discriminator interact? Well, it's a sort of cat and mouse game, and this dynamic is why it's called the generative adversarial network. The generator tries to produce fake data, while the discriminator tries to tell if the data is real or fake. They are, in essence, competing in a game, each trying to outsmart the other. Alright, so generator is feeding fake data to the discriminator. The discriminator needs to tell whether the data that is being provided by the generator is real or fake. Alright, the ultimate goal is to have a generator so skilled at creating data that discriminator can't tell real from fake. In mathematical terms, this is when the system reaches the Nash equilibrium. When the generator's data that it is generating, the fake data, cannot be distinguished from the real data by the discriminator, it's called we say that the system has reached the Nash equilibrium. The key takeaway from this is the interaction between the generator and the discriminator forms the backbone of how GANs operate and improve over time. So let's study the training process, how exactly the training process goes. So it involves a number of steps. I'll explain each step in detail. Now that we understand the key players, let's dive into how they are trained. The training process of GAN happens in a loop, often described as an iterative algorithm. So step 1, the generator creates fake data using random noise as an input. Step 2, the generated data and a sample of real data are both fed into discriminator. All right, so one real data and one fake data is fed into the discriminator. Step 3, the discriminator evaluates both sets of data and gives a probability score, aiming to get as close as 1 for real data and as close to 0 for the fake data. So the discriminator basically finds a probability of a data to be real. So it should ideally give 1 to the real data and 0 to the fake data. But the generator's aim is to bring the two scores as close as possible. And when they become same, like zero point 0.9 and zero point 0.9 for the real and the fake data, it is said to have reached Nash equilibrium. And those are the models that we actually use to produce final results. Step 4. Both the generator and discriminator update their internal parameters based on these scores using a process called back propagation. So, whatever scores the discriminator is giving, the generator and the discriminator, both of them adjust their internal mathematical functions so that they can become better. So, generator is improving with every iteration. It knows what mistakes it has made, but the discriminator is also getting better with every iteration. And that is why it takes a lot of time to reach this Nash equilibrium, and it takes a lot of computational power as well as a lot of electricity to get to that. And that is the only major drawback we have with GANs. We'll discuss this in detail in the later slides. So the cycle continues until either a set number of iterations are reached or the generator becomes as good as a discriminator. And the discriminator can no longer differentiate between real and fake data. So reaching the Nash equilibrium is obviously the main aim. But if the number of iterations are very high and we can't do that, and we are okay with, let's say, a certain degree of fakeness in the images that we have produced, but we have to save the computational power, then we fix a number of iterations. Right? Only go for, like, let's say, 1 million iterations or 1 billion iterations. Don't go the whole way. Yes, even 1 million iterations are not enough to get to the Nash equilibrium. All right. So this is how it actually happens. I'll summarize this thing for you once again. So this is the image. A random noise is fed into the generator. The generator generates the data according to this random noise that it has. Now the real data and the generated data are fed into the discriminator. The discriminator has a certain output. It gives both the data's probability of being real from 0 to 1. Of course, the probabilities are from 0 to 1. And based on those probabilities, there's a back propagation. The generator learns what mistakes it has made and adjusts its own mathematical function to produce better data or more realistic data. While the discriminator, if the score starts to get closer between the real and the fake data, the discriminator also changes its mathematical function so that the scores can be further apart, so that the discriminator is able to discriminate between the real and the fake image in a better manner, right? So discriminator is making it difficult for us to reach the Nash equilibrium. Generator is trying to reach the Nash equilibrium. And when the generator becomes so good that the discriminator is no longer able to distinguish between the real and the fake data, we reach the Nash equilibrium. All right. But reaching the Nash equilibrium is not always the aim, as it takes a lot of iterations to actually get there. So we set a number of iterations that we are comfortable with, and that is where we take the model and use it for professional use. There are certain cases where Nash equilibrium has been very important to reach, like in the medical field when we try to detect certain diseases based on MRI scan or CAT scan. But in most of the cases, also in Chat GPT, if you take one example, Nash equilibrium hasn't been reached. Okay. And that is why we get wrong answers sometimes. Loss function. So you may wonder how exactly the generator and discriminator learn from their mistakes. Right? The answer lies in the loss function. A loss function is a mathematical equation that calculates the difference between the predicted output and the actual output. The aim is to minimize the difference during training. For the discriminator, the loss function usually tries to maximize its ability to correctly classify real and fake data. Basically, for the generator, the loss function usually aims to minimize the ability of the discriminator to distinguish its generated data as fake. These loss functions are optimized using algorithms like stochastic gradient descent during backpropagation. In a sense, loss functions act as the rule of the game, guiding how the generator and discriminator will adjust their strategy. So, one loss function sits in the generator, and another loss function sits in the discriminator. The purpose of the loss function in the generator is basically to uh, fool the discriminator and make the difference between the probability of real and fake image. While for the discriminator, it's completely opposite. For the discriminator, it's to increase the difference in probabilities for the real and fake image. This topic is highly mathematical, and the whole concept of GANs is a highly mathematical concept. If you're interested in the maths, it's all available on open source platforms. And I would recommend you, if you want a career in AI, ML, or such fields, you need to strengthen your mathematical skills, mainly integration, differentiation, and statistics. These are the some of the topics that you have to compulsorily strengthen a lot. All right, because everything that you see happening, changing, are all just simple mathematical rules, right? Because at the end of the day, it's just ones and zeros in the computer that have to be calculated again and again and again. And we have to improve that mathematical formula that we have, that we call the model. The generative model that we have is nothing but a mathematical formula. That's it, right? You put in some numbers, it gives out some numbers. Either you can convert that into a text, image, whatever you feel like. All right. So I hope this much is clear. Moving on to image generation. One of the most prominent applications of GANs is in the field of image generation. I hope you all have generated a few images using AI. Either it's Leonardo or Bing Image or uh, any such tool that you have used in AI. All of them are based on GANs. So, from creating photorealistic faces that don't exist to generating artworks, GANs are revolutionizing the digital creativity. So, here you can see we have asked GAN to actually switch zebras to horses. And in the next image, we have asked it to change horses to zebras. It's not perfect, I know. The zebras still look like zebras, and the horse still looks like a horse. But you can see that we have a certain success. This is state of the art currently. This is the best that we can do, but you can see that there is a certain degree of success that we have been able to achieve in the past 6 7 months. Prior to that, the GANs was so extensive, so consuming that we couldn't even imagine using them. But with the coming of Chat GPT, uh, OpenAI has reduced the power consumption to a level where it is actually possible to use GANs in a number of applications, not just for text generation. Okay? All right. So, for example, GANs can produce realistic images of animals, landscapes, and even medical scans that they have been used in movies for special effects and even fashion in creating new clothing designs. Okay? So the technology is powerful enough that it can dream up an entire virtual world useful in video games designs and virtual reality. Let's have a look at data augmentation. Another significant application of GANs is data augmentation. In machine learning, having a large, diverse data set is crucial for model accuracy. However, obtaining such data set is not always feasible. GANs can generate additional data that is consistent with the original data. This is invaluable in fields like healthcare, where medical images are scarce and expensive to collect. For example, GANs can generate variations of MRI scans that help improve the performance of diagnostic algorithms. For example, a real life example that we have used GANs for is detecting brain tumors. Well, we had very limited data about brain tumors, a very limited number of CAT scans and CT scans. Using GANs, we generated thousands and millions of more images. Basically, that looked very real. Okay, that looked exactly like real, but with a little bit of change. So now we had data to actually feed into a machine learning model that could actually detect whether a person has brain tumor or not, or what is the probability of a person to have a brain tumor or not have a brain tumor. Is it correct? Is it clear? So basically, what happens is, I'll explain this to you once again because it's a very important thing. So in machine learning algorithms, we need a lot of data. Collecting this data is not very easy sometimes. It's not like social media, right? When we are talking about medical data, nobody is putting their data on internet. So, a practical application that we have used GANs for is detecting brain tumors. So, initially we had very limited number of images of brain tumors, CAT scan and CT scan images. So, we used a GAN model to generate new, a little bit different, but completely realistic images of CAT scans that would be for brain tumors. So eventually, we had millions of images of brain scans that had brain tumor and millions of images of brain scans that did not have brain tumor. So we fed that into a machine learning model, and it was finally able to very accurately provide the result whether a person would have brain tumor or not. All right, the success rate was very high after we fed it with so much of images, with so many images. So basically, the more the data, the more accurate the data, the better the machine learning model. That's given. All right, because machine learning model only learns from the data. That's it. Cool. So let's move on to the next slide. What are the other applications? Okay. While image-related application may dominate the limelight, GANs are far from limited to this domain. They have a variety of other interesting applications, like natural language processing. So this is one of the favorite things that a lot of students are using these days, mostly to solve their college assignments, I guess. GANs are used to generate textual content such as poems, stories, and code. They help in tasks like translation and summarization. So you can give it a story, you can give ChatGPT a story, it would summarize that for you. So these are some of the things that it can do. It's called natural language processing. It understands what the person wants to say. So you don't always exactly say, uh, and you don't always exactly mean what you say. So finding out the context from it is the real challenge that AI ML field has been facing for a very long time. But with GANs and very good discriminators that have come into the market, very good discriminator loss functions, we were able to actually generate something at OpenAI that would give you very good result at natural language processing. Although it hasn't reached its Nash equilibrium yet, it has been going on for months now, but it hasn't reached it. We have had billions and billions of iterations, but it's just not reaching the Nash equilibrium. Let's hope it reaches there soon, and ChatGPT will then become just like a real human. Okay. The next is gaming. GANs can be used to create more interactive and realistic gaming environments, enhance game design, and even develop new game levels automatically. So if you give it 10 levels for a particular game, it will generate the 11th level. It will learn from what the earlier 10 levels were and what kind of game do we have. It will automatically generate the 11th level. Okay, so it has started to work on very basic games, but it hasn't been able to work on complex games yet. But we are hoping that this comes out soon, and it would completely revolutionize what gaming means. And finally, gaming would also be something very realistic, Whether like there'll be a lot of options in games, what you choose, GAN will generate a new thing according to that. So that's going to be wonderful for anyone who plays video games. The next is art. Artists are using GANs to create new types of art or to collaborate with machines in the art making process, forming a new art genre often called as AI art. So AI can generate art. It can mimic any artist from the world that is famous enough that like, basically the machine learning algorithm should have enough input data to replicate. So in art, it is playing a major role. So let's go for some case studies so that we can clearly understand what's happening. So the first case study, healthcare, enhancing MRI scans. One impactful application of GAN is the healthcare industry, specifically in enhancing quality of MRI scans. A research group utilized GANs to generate high resolution MRI images from low resolution inputs. So MRI scans are not always very clear. There are machines that give very clear MRI scans, but they are really expensive and they are not available in most of the nations. Even if they are available, they are not affordable by most of the people. So, what do GANs do if you feed it a bit unclear data? It will clear it for you. Basically, it will make the MRI scan high quality or high resolution. Not only does this improve the utility of each scan, but it also lowers the cost by reducing the need of rescans or multiple types of scans, making healthcare more accessible. The key takeaway from here is GANs are poised to revolutionize medical imaging and diagnostics, ultimately leading to better healthcare. So this is where GANs are currently actually being used. Okay, these are practical applications that are currently going on. These are not something that will happen. This is not something that will happen in the future. It's the present scenario. Case 2 is entertainment, deep art, and AI generated art. I hope all of you must have seen some of it, some of the images created by AI. Another captivating example of GANs in action is in the world of art. With a platform called Deep Art that allows users to turn photos into artwork styled after famous artists like Van Gogh or Picasso. This isn't a simple filter, okay, like you put on images. It isn't a simple filter. The GAN understands the style of each artist and applies it to a completely different image, essentially creating a new piece of art. The platform has garnered significant attention and poses intriguing questions about the nature of creativity and the role of AI in art. So it's so realistic at the moment that you won't be able to actually identify which is a real Picasso and which is a fake Picasso. I mean, if you are an avid Picasso, if you have actually seen all the images, like all the paintings, you would know that this never existed. But apart from that, if you didn't know, if I put 100 images of Picasso's paintings mixed with 10 fake images, you won't be able to identify which paintings are real, which are not. So I think they have reached the Nash equilibrium, but I haven't. I don't have the up to date information on that. All right. So the platform has garnered significant attention. Of course, it's so good, and it has greatly increased the role of AI in art. So the key takeaway here is GANs are not just tools, but also collaborators that expand the boundaries of what's possible in artistic expression. All right. So as it was earlier believed that art cannot be replicated by AI, art cannot be understood by AI because it required IQ. That belief has been questioned with the coming of these new technologies. So that's something that is very different and something that was not really expected. Let's go on for the third case study, retail, personalized fashion design. So let's turn our attention to our retail industry where GANs are making waves in personalized fashion design. A startup used GANs to personalize clothing items for customers. Users could upload a photo of themselves and the GAN would generate styles that match their individual preferences and body type. This technology offers a unique customer experience, breaking away from the one size fits all approach to fashion retail. It enables brands to offer personalized recommendation at scale, something that was not feasible before. GANs are democratizing fashion. making personalized style accessible to a broader audience. So personalized styles were available for the rich and famous always. But for the general audience like us, getting a personalized stylist was always a dream or out of our affordability. But now with the coming of GAN can become our personalized stylist. And it has. A startup has actually used it to give personalized feedback to their users as to what they should wear and what would actually look good on them. And you can also upload your own clothes onto it, and it would understand what kind of clothes do you like. So that is a major jump, and that is actually an expert's job. So there are two types of jobs, okay? Menial jobs and expert jobs. AI was always supposed to take the menial jobs, right? Like driving a car, etc. But the experts' job were the ones that were believed to be completely safe and couldn't be affected by AI. But with the coming of these technologies, as I've already told you, AI has become an artist. It has become a fashion designer now, and it is actually uh, taking up experts' jobs. So that is a major hurdle for people who are experts too, right? So you actually have to polish your skill to a level where you can compete with the AI now. All right, let's go for the next case study: environment, climate modeling, and data simulation. Our final case study takes us to the realm of environmental science, specifically in climate modeling and data simulation. Researchers have used GANs to improve the quality of climate models by generating realistic weather patterns. This aid in better understanding the impact of climate change and assist policymakers in making informed decisions. The traditional climate models are computationally expensive and take a long time to produce results. GANs help to speed up this process while maintaining or even enhancing the accuracy. GANs hold the promise of making complex climate modeling more efficient and accurate, which could be a critical asset in tracking climate change. So, where is this useful? One very good example would be floods. If we already knew some place was going to get flooded, we can send suitable resources to help the people out. If we already knew that next year there'll be a drought, we can save up some water in our dams and be prepared for it. And if we already knew there were going to be a cyclone, we can warn people much in advance, and they can pack their stuff and leave safely, right? So these are the applications of having a better climate model that is less computationally expensive. So we already have models that are pretty accurate, but the computational cost is so high that it's not feasible to calculate for the whole earth all the time. But with these new models, it might be, it hasn't achieved the goal yet, but it might be able to predict the weather of the whole globe all the time, like at least 1 week in advance. So that is basically the goal for this climate model and data simulation. So with this, we are reaching the ethical considerations. That was what GANs can do. Now we'll see what are the ethical considerations behind that. So one major problem that we are facing are deep fakes. While GANs offer numerous benefits, they also pose ethical challenges. One of the most discussed issues is the creation of deep fakes. Deep fakes are hyper realistic videos where a person's likeness and voice are replaced by someone else's. They can be used to satire or entertainment, but there is a dark side: misinformation, identity theft, and manipulation. Imagine someone can make a video of you saying whatever they want and publish it on YouTube. So that is a major hurdle that we have when it comes to GAN. They are able to make such good deep fakes that it is completely indistinguishable, even by humans, as to what is real and what is fake, which video is real, which video is fake. So that is something that we have to take into consideration and set up rules or put up rules to prevent that from happening. So, for instance, deep fakes can be used to create fake news, misleading political videos, or impersonate individuals for fraudulent purposes. So, what is the key takeaway here? The ease with which GANs can create deep fakes demands rigorous ethical and legal framework to mitigate misuse. All right. The next thing is data privacy. So another ethical concern with GANs centers around data privacy. GANs often require large data sets for training, and these data sets may contain sensitive information. Even if a GAN is trained on anonymized data, there is a risk it could generate output that can be reverse engineered to identify an individual. This poses significant data privacy risks. Furthermore, in application like healthcare, misuse of data can have severe consequences, going beyond privacy infringement to impact people's lives directly. So, as we advance in our utilization of GANs, data privacy must be central consideration to protect individuals' right. So, a lot of data has to be fed into machine learning models, right? So, the major thing that we are discussing here is data privacy. How is it breached? So, when a lot of data is fed into machine learning models, we don't necessarily check what kind of data we are feeding. Anything, maybe from a particular social media site, is fed into the machine learning model. It might contain sensitive information as people are not very conscious about what they post on social media. And if GANs are asked questions numerously, like again and again and again, they can reveal the identity of the users. That is the problem that we have faced in the past. And that is why a lot of better GAN models are not being able to made. We are not being able to make them public because they have these problems that needs to be solved. So as soon as we are able to come up with better solutions, we'll go ahead and you'll get much better GANs working for you in the future. So the future would look something like this. There is a CEO in the company and there is nobody else. The entire tech company being run by a single person. All other employees can be GANs. Right? That is something that we want the future to look like. Machines to work for us and we have time to enjoy. All right. So there is also a problem of bias in GANs. A less obvious but equally important ethical issue is the potential for bias in GANs. Since these data models are trained on large data sets, they can inadvertently learn the biases present in that data. For example, a GAN trained on a data set of faces that lacks ethnic diversity may produce results that perpetuate racial biases. Similarly, in applications like job recruitment, GANs might reinforce gender or other biases if trained on skewed data set. I'll give you an example of that. Let's take data of a company which has around 80% males. Okay, we fed that data into our machine learning model. Now the machine learning model automatically learns that if the gender is male, the person has higher chances of getting recruited. Although that's not true, the person might or may not be better than the person that has female gender, but because our data was such, our data was biased, the machine learning model automatically learned that it needs to hire male candidates more. So such biases can get into our machine learning models that we have in our data sets. So we need to prevent that. We have to provide non-skewed data to the machine learning models. So bias in GANs is not just a technical issue, it's a real life scenario application. It could reinforce stereotypes and create unequal opportunities, undermine the principle of fairness. Key takeaway: being conscious of the biases in training data and actively working to mitigate them is essential for ethical GAN deployment. Okay? So that is something we need to look into. So it's more about there is bias in real life. So the data that we have is also biased according to that, and that is what is getting into our GANs model. So we need to prevent that somehow. We haven't been able to find any solution to it so far, and but we are working on it. We haven't been able to prepare even a theoretical concepts that would save us from this, but we are working on it nevertheless. Limitations and challenges. So, what is mode collapse? While GANs have impressive capabilities, they are not without their challenges. One such challenge is mode collapse. Mode collapse occurs when the generator starts processing too much data
Hello, everyone. There is a slight network issue from our speaker's side. We'll be resuming the session in few minutes. I hope till this time the session was exciting. I find it exciting.
All right, really sorry, guys. There was a connection issue, I guess. So let's continue. So you're trying to understand what is mode collapse. Okay. So while GANs have impressive capabilities, they are not without their challenges. One such challenge is mode collapse. Mode collapse occurs when the generator starts to produce a very limited variety of outputs, essentially fooling the discriminator with the same or similar image repeatedly. This defeats the purpose of a GAN, which is to generate diverse, high quality data. When mode collapse occurs, the utility of GAN is compromised. So, addressing mode collapse is critical for improving the reliability and applicability of GANs. So, what happens is when we are training uh, our models, what happens is sooner or later, before it reaches the Nash equilibrium, sometimes it gets stuck. The mathematical model behind it stops getting updated. So that is when mode collapse happens. Imagine after 1 year of very learning a lot of iterations, very high computational power, spending a lot of electricity, your model reaches mode collapse. So that would be something very sad for the company, and it would severely hamper their future plans with a particular GAN model. So we have to find ways so that the GANs do not reach mode collapse or never reach mode collapse. We haven't found that yet. There is always a chance. There is always a chance that your model will can reach mode collapse. Okay, that is a limitation with current GAN. Maybe in the future we are able to completely eliminate it, and a lot of scientists are working on it. So cool. So limitation and challenges, the computational resources. Another major limitation is the computational resources required for training and deployment of GANs. Training a GAN often involves high computational power and memory, making it resource intensive and sometimes inaccessible for smaller organizations or individual developers. Additionally, real-time application of GANs like video generation or game rendering demand robust hardware capabilities, often requiring specialized equipment like high-end GPUs. So the key takeaway here is the computational requirement pose a barrier to the widespread adoption and scalability of GANs. If we are able to reduce uh, the computational requirement for GANs to a level where it can run on a personal computer, that is when the true potential of GANs would be realized, and everyone on their own computer would be able to generate new videos, images, text, and everything that they actually require to generate on a daily basis. You can make whole video games just by entering one text. What kind of a video game do you want to play? And the GAN will actually generate the entire levels, characters, backstory, videos, graphics, everything for you. Imagine something of that sort. All right. So let's move on to some advanced topics. Basically, what are the various areas of research that are really hot at the moment under GAN? So as we delve into advanced topics, let's start with conditional GANs. Unlike standard GANs that generate data from random noise, conditional GANs allow for guided generation based on certain conditions or labels. So instead of starting from random noise and generating random data, then improving upon it, conditional GANs have certain conditions based on which the data is generated. So of course, this will reduce the number of iterations to reach the Nash equilibrium. That is what the research area is all about. For instance, you can condition the GAN to generate images of cats, but specify the color, size, or even pose you want the cat in. This adds a layer of control to the generation process. Application ranges from more targeted data augmentation in healthcare to customized product design in retail. So conditional GANs provide more controlled way of data generation, expanding the range of practical applications that they have. So the next advanced topic is style GAN. Another advanced topic in GAN landscape is the style GAN, a variant that allows for incredibly detailed and flexible style control. Style GAN uses a concept called style mixing that enables the creation of intricate and complex images by combining different styles at multiple scales. This has been notably used in generating hyper-realistic faces as well as art creation where even minute style details can be manipulated. So style GAN pushes the boundary of what's achievable in data generation, offering unprecedented control over style aspects. Okay. Another area is metrics. So evaluation of performance of GAN is not as straightforward as traditional machine learning models, given the lack of a single objective function to optimize. So all machine learning models have something called as an objective function. An objective function has to be optimized, that's it. But that is not the case with GAN. GAN has two components, generator, discriminator, and they are fighting each other, right? So there is no single objective function that has to be optimized. Common metrics include inception score, Frechet inception distance, but these are highly mathematical concepts. You can Google them. They are open source. All the mathematics behind it is available. Everything is available. How to drive that maths, why that maths is working. So you can have a look at it if you are interested. So they assess the quality and diversity of generated images respectively. However, it's crucial to remember that these metrics have their limitations and should be used in conjunction with qualitative assessments. So, the key takeaway here is rigorous evaluation is essential for ensuring the effectiveness and reliability of GANs, necessitating a blend of qualitative and quantitative methods. So, it is being researched as to what evaluation metrics can be included to find out if the GAN is working better than before or not. But it's an area of research. We haven't been able to find the perfect metric yet. So, to conclude, generative adversarial networks are a transformative technology with wide ranging applications from image generation to climate modeling. However, it's important to consider the ethical implications, challenges, and limitations associated with GANs. As we have seen, advances like conditional GANs and style GANs are pushing the boundaries of what is possible. GANs are a powerful tool but come with responsibilities and challenges that must be uh, consciously managed. Looking forward, GANs will likely see improvement in computational efficiency and effectiveness in dealing with issues like mood collapse. We should also expect a rise in applications ranging from personalized medicine to increasing interactive and realistic virtual environments. The future of GANs is promising but requires ongoing research and ethical considerations as well. Okay. So the stage is open for Q&A. If you have any doubts, let us know and we'll be more than happy to answer you. Thank you so much, guys. If you have any doubts, let us know.
Thank you so much, sir, for introducing us to this amazing side of Nero AI and how much importance GANs hold in this field. Hopefully, our participants must have grasped some interesting knowledge on this topic as well. Moving ahead, we will now start a quick question and answer session. Therefore, audience, if you have any question or concerns about the topic, feel free to post them in the comment box.
So here the question asked by Chandana is, what is the most post by post threat by GANs?
All right, the most posed threat is it might take your job. To be very honest, if it does expert, if it is equal to an expert, it is much cheaper and much faster and can improve at a scale that has it is impossible to even imagine as compared to a human. So the most uh, the worst case is it can take your job. But obviously, it has already been programmed not to destroy Earth, not to destroy humanity. So that is just for the Hollywood and the Bollywood movies. It won't do that. The worst it can do is take your job.
So the next question is by Alisha Fatima. The question is how data privacy can pose a threat with the help of GANs.
Okay, how is data privacy? All right, so data privacy is something that is basically we have to filter out the names and make the data anonymous, and then the data privacy doesn't affect anyone, right? If we just take a consensus as to on Facebook how many people are from the age 20 to 30, that doesn't pose any risk to your data. But if we take your entire data and feed it to a machine learning algorithm like the GANs, then it can be reverse engineered to get out your to take out your personal data. Like if you keep asking that model questions pertaining to a personal to a particular person, it might answer back like give me all the credit card details that you have. It might answer it if people have posted that on social media. So the GAN model trained on that particular model might answer you. It might give you all the credit card details that it has in its database. So that is how privacy is compromised. If we feed in all the images from social media, so there might be images that are you don't want everyone to see or you don't want to be replicated. So that is another aspect. Deep fakes. So that is how privacy can be breached if we make use of GANs without the ethical uh, and legal system behind it. Yeah.
So the next question is by Sujana, and the question is which disease is detected with the help of GANs exclusively.
All right. So no disease is currently being detected just by an AI model. You always need a doctor. All right. It is just there currently to help the doctor in identifying certain diseases. So it basically raises a flag after an MRI scan if you have a brain tumor, if you have a high probability of having a brain tumor. Finally, the doctor will have a look at the MRI scan and tell you whether it's there or not. So there is no disease currently being diagnosed by any AI in the world.
Okay. So the next question is by Alicia. What are the job possibilities in this field?
So the first job possibility is data scientist. You can apply for that role. For that, you need strong mathematics and a keen interest in this field. That's it. So these are the two requirements. If you have that, you can apply for data scientist roles. And the new startups are paying handsomely for this role. So you can have a look at it. You can go to LinkedIn, find some jobs related to that. And if you are not able to, you can connect with me. I'll help you out.
So Vedant Dixit asked, what is a cycle GAN?
All right. So basically, GAN works in a cycle iteratively. All right. What happens is the generator generates a particular kind of data. The real data and the fake data is fed into the discriminator. The discriminator gives the probability from 1 to 0 of a particular image of being real or fake. The output is again sent into the generator, and that is why it is called a cycle GAN. It goes on iteratively round and round until the difference between the real image and the fake image vanishes.
Uh, so the next question is from Sanket, and the question is, how can the deep fakes can be dealt with, as it can be create dangerous conflicts?
All right, so deep fakes, to tackle deep fakes, we are training other GAN models to identify between a deep fake and a real image. So GAN will itself take care of it once we are done with that. So AI will automatically detect if something has been generated by AI or not, whether be it deep fakes, paragraphs, texts, videos, images, anything.
So okay, and that concludes the question and answer session. And we appreciate you very much, sir. And we would like to extend the token of our appreciation. We really are honored to have you here, sir. Certainly, our participants gained new and exciting knowledge regarding the topic of technology behind the creating a virtual person.
Thank you so much, sir, for joining us. Last but not least, I want to express my gratitude to all the attendees for their support. Good luck to everyone, and remember that tomorrow's hands on session will make use of knowledge you gained today. We'd like to express our gratitude to our sponsors for their support, starting with HP, our technical sponsor. HP is an American multinational information technology company headquartered in Palo Alto, California, that develops personal computers, PCs, printers, and related supplies, as well as 3D printing solutions.
Our streaming partner is StreamYard. On the StreamYard platform, you may broadcast over social networks directly from your browser before choosing the premium plans to gain access to more features. It provides a free option that you may test out.
Thank you for being such a great audience. We wish you all the luck for your upcoming endeavors and hope to see you in our next session, Computer Vision of Epsilon 2023.
All right, thank you so much, guys, for having me over here. And I really liked it to connect with students. And if there's any further problem, you can always get back to me. Thank you.
Thank you, sir.
Thank you, sir.
And there's an
Thank you.
announcement for the audience that the test and the quizzes link will be introduced in the comment box. So do participate in the quiz. I would request the audience to hold on for a few minutes. The link is being introduced in the comment box. So attendees, the quiz link is being introduced in the chat, in the comment box. We hope you participate. Do participate in the quiz. And make sure once you've completed the quiz, you also fill the feedback form. I thank you all for joining this session. We hope to see you in the next session of Computer Vision of Epsilon 2023. We'll be closing in 10 minutes, so make sure you fill the quiz, you give the quiz in those 10 minutes. And the next session will be of Computer Vision of Epsilon 2023, which will be starting on 12:30. And we also hope to see you in that session as well. You can find the Computer Vision of Epsilon 2023 in the comment box as well.